Hello students, in the last lecture I talked about the beginning of modern architecture, that the foundation was laid in the 18th century, and I talked about the rise of Neoclassicism, and I talked about its early stage which was known as rational Neoclassicism. I had also mentioned that when you look at these buildings, for example the very building that you see on the first slide, this is the main building called the James Thomason building of IIT Roorkee. It's purely done in the neoclassical style. When you look at this building, it shows you or it connects you with classical architecture. But is there the rise of modern architecture here? Of course, because the same principles then were carried on into the 20th century. Now, one major development that took place in the 18th century was the rise of archaeology through Herculaneum and Pompeii. Now, I am not saying that archaeology was not there before, but this particular discovery played a very important role. The reason was Herculaneum and Pompeii were two cities of the Roman times that had been buried when Mount Vesuvius erupted. It's volcanic, it erupted, and in a very short time it had completely covered these two cities, so much so that that people could not even escape in time, and they got frozen where they were when the volcano's molten lava and its flow entered into the cities. How do we know that? Because in the 18th century they discovered or excavated these two cities, and when they excavated them, these two cities came out more or less as close to intact, very much intact, that they could see the precise proportions of classical architecture, classical geometry in these buildings that were excavated, Herculaneum and Pompeii. Like I said, even people were frozen and they have been found exactly in certain positions. This discovery led them to draw these classical order columns, for example, and classical details, and they started drawing them, putting them together in measure drawing. And these archaeological and scholastic studies helped them to understand classical proportions in precise detail. And the impact was that then the buildings started coming up. For example, after the archaeological phase, in the radical phase of neoclassical architecture, the proportions were very well understood. Now, one building which is, you can connect it to the idea of the assembly halls at York, which was an interpretation. In this radical period, there came up a building called the École de Chirurgie, the School of Surgery, by Jacques Gondoin. In this particular building, which was actually a college of a medical college, a school of surgery, he took very different elements, and like Richard Boyle, he combined them together to form this college or school of surgery. For example, in this entire plan that you see of the School of Surgery, you find that he borrowed the main anatomy theatre here. You entered from here, you reached a courtyard, and the anatomy theatre were right in front, and this anatomy theatre had this temple front that you see here, and this is the temple front that you see in the plan. Then you had the Corinthian colonnade on all sides, borrowed again from classical architecture. You had the Roman triumphal arch, which was used when the victorious Roman generals used to enter Rome. They would erect a triumphal arch to commemorate that victory, and he converted the entrance of the School of Surgery using the triumphal arch from Roman architecture. Now, how to seat the people, how to arrange for the seating within the anatomy theatre or the lecture theatre. If you see this in plan, it is so similar to the amphitheatre of the Roman times. So he put together the seating, as you see in this small picture here, that the seating is using the amphitheatre, and from top the light is filtering from a half oculus that you find, the full oculus you would find in the Pantheon. So he used the Pantheon dome with the oculus, the half oculus, and it was covering the amphitheatre. The amphitheatre idea, of course, then has been used in or rather is used in modern architecture also. And radical neoclassicism then moved into a world which was very radical alteration of classical geometry, and that was through the works of Claude Nicolas Ledoux. Claude Nicolas Ledoux was an architect who was given the architectural commission to make the toll gates to Paris. There were about quite a few toll gates that had to be made all around the city of Paris. He took that, each one of them, as an architectural venture, and he radically modified classical geometry. For example, you see here that he makes the columns flat, or he takes the classical temple front and mounts it with another classical building, which is a completely radical combination. Or he completely modifies the arch and he provides this features of the keystones, he pushes them on the outside. He changes the entire geometry of buildings, though they look in appearance to be borrowed from classical architecture, but they are radically different. Then Claude Nicolas Ledoux moves on from radical to visionary neoclassicism, and he starts designing buildings that could not be executed structurally all the way until the 20th century. These buildings, which were pure geometrical forms, are so similar in idea and concept to the pure geometrical forms that we see today in our buildings. This is a project that he envisioned. It was never built. He envisioned it as an ideal city of shore, where the house of the supervisors was made over the river Ledoux, and in this house the river flows from within the house through a tunnel. There are windows which are looking out towards the landscape. There are windows inside the tunnel looking at the water that is flowing through this pure geometrical form. Now, if you see this pure geometry, you start realizing how quickly the architects of this period have moved from the pure classical forms that you find in Greek and Roman architecture to understanding the core principles of pure geometry behind classical architecture. They have completely, Ledoux in his vision has completely eradicated those Corinthian columns or these Greek order columns and other facades completely. He began first, like here, by radically modifying them, then he completely does away with them in his vision and goes with pure geometry. Now, this pure geometry, I would like to compare this house with Falling Water, which is built on a waterfall, and both are void of decoration, both have a powerful scale, both are an interplay of pure forms, and both have a very close knit relationship with the surrounding landscape or the surrounding environment. And so what you find is, what he envisioned in the 18th century as a pure solid geometry, in which the river is flowing through the house, has come alive in the 20th century, in 1936, with this Falling Water, one of the probably the most famous house of the 20th century by Frank Lloyd Wright. Now, not only pure geometry was brought in or envisioned by Claude Nicolas Ledoux, it was also envisioned by Étienne-Louis Boullée. Boullée was more of an academician, and he was tremendously influenced by an artist called Giambattista Piranesi. Giambattista Piranesi, and I don't have a picture right now, but if you look it up online, you will find that Giambattista Piranesi generally used to make paintings that are very dark theme. He used to paint ruins, he used to paint prisons, he used to present a very dark and gloomy atmosphere in his paintings. Boullée borrowed, or rather was influenced by Piranesi's paintings when he also started envisioning architecture. They were never built. He went in for a pure form. This is called the Cenotaph to Newton. The Cenotaph to Newton. First of all, these are some of the pure geometrical works of Claude Nicolas Ledoux. There is the Cooper's workshop. Coopers are those who manufacture beer barrels. So he takes the beer barrel itself and puts that into the x, y and the x axis and the y axis, and he makes this these two beer barrels cylinders interpenetrating each other. Then he goes in for pure spheres. He envisions this entire building as a pure sphere. And then it was Boullée who also envisioned a pure sphere when he thought of a cenotaph to Newton. Cenotaph is a false tomb. It's more of a memorial. The tomb is elsewhere. An example for that is the Taj Mahal. If you ever visit the Taj Mahal, you will find that the graves, or the tombs rather, of Noor Jahan and Shah Jahan are not, of Mumtaz Mahal and Shah Jahan are not the ones that you see above. The actual tombs are inside. You have to go underground in the basement to see the actual tombs. So, the ones which are above are cenotaph, representation but not the actual tomb. As a tribute to Isaac Newton, Boullée envisioned the cenotaph to Newton, which had a combination of light and shade, this same dark and gloomy environment of Giambattista Piranesi. He envisioned the building like that, and the amazing thing is this building has got what he envisioned was, it will have holes in it, the inside will be a complete hollow, it will have holes in it. So, in the daytime when the light filters in, it will look like a night sky with stars. In the night it will have a huge lantern hanging in it and light it up like it is daytime. So, it reverse, day to night, night to day, and he envisioned this as it's a massive monumental scale, 150 meters high. Greater than equal to 150 meters is what the height, what we define as the height of a skyscraper. At 150 meters is the beginning of a modern skyscraper. This is as high as a modern skyscraper. So you can imagine how this sphere is a 150 meters wide also. And these are the height of the trees. If you look closely in the picture, these are the height of the humans. So this is monumental, super monumental scale, mega monumental is what I would call it. And this vision he carried into other buildings. He always imagined buildings on a monumental scale, whether it was this pyramid he envisioned, this building, or for example this one, and you can see that these are the humans. It's such a huge scale. Did anyone learn from this? Yes. This idea of this megalomonumental architecture, the light and darkness, was adopted by Albert Speer, who was a Nazi architect. He was the architect to Adolf Hitler during the World War. And in order to have their rallies, what he thought was that these lights are what is used to project towards the sky to see enemy aircraft when they are flying in the sky. These are these huge spotlights. What they did was they used these spotlights, raised them flat up so that the light would just go straight up like that, and when they put a large number of them in a pattern, it would form like a monumental cuboid, a monumental room, and in that their large Nazi rallies would be held. And it has a very dark and gloomy perspective, very dark and gloomy vision, which was what Boullée had, which he had himself borrowed from the artist Piranesi. Put it simply, Albert Speer was impacted by Boullée's megalo-monumental architecture, create that dark and gloomy environment, and to use these lights to create that mega monumental scale. Now, this idea of this classical architecture, monumental scale carried on because the plan of Adolf Hitler was to completely lay out the 1000-year rule of the German Empire, like the Roman Empire, and these buildings that were built by the Nazis also had monumental scale. For example, you can see here, these are the humans here, and this is the scale of this building, this stadium that was built. Or for example, the buildings that he envisioned that would be built in this capital that Hitler had envisioned, Albert Speer thought of this building. You can see this is the vision inside, these are the human scale, and it is mega monumental like that of Boullée. There is actually a visionary building done by Boullée which is very similar to the one envisioned by Albert Speer. Now, geometry per se, pure geometry that Ledoux actually envisioned and Boullée envisioned, came alive in the 20th and the 21st century, because now we had the structural and material technology to build these kind of forms. For example, we find that in the Sydney Opera House, we find that in the Gherkin, the Swiss rebuilding by Norman Foster, we find that in the Sher-e-Bangla assembly in Bangladesh, or we find that in the Baha'i temple. We find that in the water cube It is a complete cube and made out of this material. Maybe we will again look at it later. Or it is for example in the John Hancock Center, which is tapering towards the top, or the pyramid by IMPI, the glass pyramid, or the Aldar headquarters in the UAE, this massive pure geometrical form. This has become possible in the 20th century. So, that vision came alive quite a while later. Then you find dynamic geometry, not just pure geometry, but a play of geometrical solids interconnected, or interplay of geometrical solids in which the geometry is dynamic. For example, in the CCTV headquarters, the tower in Beijing, which was built for the Olympic Games by Rem Koolhaas, you have the what you call the contemporary, and this is the Contemporary Jewish Museum in San Francisco. This is the Rock and Roll Hall of Fame and Museum in Ohio by IMPI, and the Heydar Aliyev Center by Zaha Hadid in Azerbaijan, in Baku. This reflects dynamic geometry. In the end, I would like to conclude the 18th century Neoclassicism by saying that it actually became an international movement. That is the definition of an architectural movement. There are many styles, but then there are movements, and movements are those which spread over a wide geographical area, from Europe to America to Asia. Neoclassical buildings came up, and thus it became an international movement. We move on from here into the 19th century, when we will study about one of the biggest revolutions that has transformed modern society, the Industrial Revolution, and how it impacted architecture and buildings. We will see that in the next lecture. Thank you.